In today's video, we are going to be doing calculations with wave speed, wavelength, time, and frequency. So before we get started, I have our formulas up in the right-hand corner, and I just want to go over what a lot of these variables mean, or just to refresh you. So V is wave speed, and that's going to be a unit of meters per second, and that's also this other V here as well. This is what we call lambda. So lambda is wavelength, and it is measured in meters. This capital T is time, measured in seconds. This is going to be the same lambda, also wavelength in meters. And then lastly, this is frequency. So frequency, the most common unit is a hertz, but a hertz is also 1/second. So those are the same thing. Jumping into our first problem here, the string of a piano that produces the note middle C vibrates with a frequency of 262 Hz. If the sound waves produced by this string have a wavelength in air of 1.3 meters, what is the speed of the sound wave? So we're solving for speed, and we're given Hertz, which Hertz is frequency, 62 Hertz. And we're given something in meters, so that's going to be wavelength lambda, 1.3 meters. Now, since we have two formulas up at the top, we want to make sure that we're using the one that has both frequency and lambda in it, and that's the one that's going to be solving for the wave speed. So in this case, that's V equals lambda F, or lambda frequency. All of our units are in the right format here, so we can just plug in these numbers. So 1.30 meters with a frequency of 262 Hertz. If we plug this value into our calculator, we should get 340.6. And now the way it looks right now is that we have a meter times a hertz. But again, 1 hertz equals 1/second. So it's actually going to be 340.6 meters per second. You want to jam to some music, so you turn on your radio to 92.3 FM. This radio station broadcasts electromagnetic waves at a frequency of 92.3 megahertz. These radio waves travel at a speed of 3.0 times 10 to the 8th meters per second. What is the wavelength of these radio waves? So for this one, we're going to identify our variables. It's asking for wavelength. So it's asking for lambda. It's given us a frequency of 92.3 megahertz, and it's giving us a speed, so a V value of 3.00 times 10 to the 8th meters per second. The formula that's going to relate all these three is going to be this one right here. V equals lambda over F. Now we need to rearrange this to get lambda on a side by itself. So we divide both sides by frequency, cancels out on the right, and it's going to leave us with lambda equals speed over frequency. Now in this, we don't have our units correct, so we need to have hertz, and right now it's giving us megahertz. So we're going to need to unit convert that. So for your unit conversions, we need to convert that back down to hertz, because mega is a really large number. 2.3 megahertz. And so for every 1 megahertz, there is 1.0 times 10 to the 6 hertz. And so megahertz cancels out, and this is going to give us 92.3 times 10 to the 6 hertz. So this is going to actually be the value that we use here for frequency. Okay, now we can plug in our values. So speed 3.00 times 10 to the 8th meters per second, all divided by 92.3 times 10 to the 6 hertz. And again, remember your hertz is just 1/second. So this is actually going to cancel out with that. This should give us a value of 3.25 meters. For our last problem, you are standing on the pier watching waves on the lake that pass by. The waves have a wavelength of 1.2 meters, and they pass the pier at a speed of 3.0 meters per second. How much time does it take for one wave to pass under the buoy? So again, we're going to line up our variables here. We're given meters, which is a wavelength. We're given a speed of 3.0 meters per second, and it's asking us for time. So it's asking us for time. So for this equation, we actually need to use the formula on the left, because here, this is what relates time, wavelength, and velocity, or wave speed is better suited for this equation. So we have V equals lambda over time, and again, we're solving for time. Now, the quickest way to do it is just switch these two variables, and that would give us time equals lambda over wave speed. How you would actually do it is multiply both sides by time. That gives you TV equals lambda, and then you would divide both sides by wave speed, and then that would give you the T equals lambda over wave speed. All of our units are correct, so we can just say 1.2 meters divided by 3.0 meters per second. Your meters are going to cancel out. It's actually going to leave you with 1 over seconds, or excuse me, it leaves you with 1 over seconds, which then you can inverse back and give you seconds. So it gives you 0.400 seconds.